The second type of improper integral is one where the integrand is unbounded or has a vertical asymptote somewhere in the interval of integration. This is an example, definite integral from 1 to 11 of 1 over the quantity x minus 3 to the 2/3 power. You can look at that function and recognize that there's going to be a vertical asymptote at x equal 3. And I've got a graph here for you. Clearly, I have not graphed this showing the entire interval from 1 to 11, but it does serve to illustrate the fact that there is a vertical asymptote there at x equal 3. To handle this type of problem, you first start by recognizing where the vertical asymptote is and breaking up your integral into two smaller integrals around that asymptote. So we're going to integrate from 1 to 3. Oops. Integrate from 3 to 11 and add those integrals together. All right, now to handle what's going on at 3, we're not going to be allowed to substitute 3 into this function or even into the antiderivative of this function. So we're going to kind of treat this the same way we did the others, where we rewrite the problem limit, in this case 3, as some variable, and then we take a limit as that variable approaches 3. So thinking about this way, hang on just a minute. Our issue is right here at x equal 3. So I'm going to rewrite that integral from 1 to maybe c for 1 over x minus 3 to the 2/3 power. And then I'm going to allow c to approach 3 from the left side. So we're going to take a limit of that definite integral as c approaches 3 from the left. The direction is important. For the next integral, we don't want to use the same constraint c, same parameter c, so let's use a different one, d to 11. And then now we're going to think d is allowed to get closer to 3, but from the right side. So we'll take a limit of that as d approaches 3 from the right. As in the last problems, we're going to work with u substitution. Again, not changing the limits. So we're going to make sure that before we start plugging in our upper limit and lower limit, we're going to rewrite any quantity that has c in it. We're going to replace the c with the x minus 3. So looking at what I've got to deal with, limit as c approaches 3 from the left of the integral from 1 to c of u to the negative 2/3 power du plus a limit as d approaches 3 from the right side of the integral from d to 11 of u to the minus 2/3 power du. Okay, I'd recommend that you pause the recording here and work those integrals and restart when you're ready to take a look at taking the limit as c approaches 3 from the left and from the right. All right, take a look at the work there. You should have remembered before you start plugging in the c and the d, before you start evaluating that antiderivative at the limits, remember you had to replace u with the quantity x minus 3. And that's a really easy thing to forget to do. I almost did that. And then substituting in the appropriate values, we are now looking at these two limits. Now, as c approaches 3 from the right side, this first term is getting closer to 0. Excuse me, I said from the right side, I mean from the left side. This limit, as c approaches 3 from the left side, the first term of that quantity is going to 0. The second term is going to positive 3 times the third root of 2. You could pull out that negative if you choose to. And then in the next limit, we've got 3 times the third root of 8. The third root of 8 is 2 minus, and that term is also going to 0. So we have another limit that converges to the quantity 3 times the third root of 2 plus 6.